All right, so if we take out our highlighter, arithmetic sequences was the first part of this unit. The second part of this unit is geometric sequences, where you get the next one by multiplying.
Will any of this up in the quiz form?
The quiz is only up to 1.2. So what we're doing today is not on your quiz. Your quiz is just arithmetic. So it'll have sequences and series, adding them up and figuring out terms. That's what our quiz is tomorrow.
Terms and sum, or the sum of the entire.
Yeah, we do the sum of arithmetic ones will be on the quiz tomorrow as well. So adding and just finding, so those three formulas and the questions that we've had for our quiz tomorrow. So we use R for the common ratio, and you can always find the common ratio by taking any two in a row and dividing. So 12 divided by 4 is 3, 36 divided by 12 is 3. Somehow I'm going to hit that error. Oh, wait for it. There it is. 108 divided by 36 is also 3. So because that's in common, that's why we call it a common ratio, and it's the value you're multiplying each time by. Sometimes, and most of the time, with both arithmetic and geometric, you can just see it. But sometimes you can't. Like if I did decimals, and I decided to multiply by, here, I'll pick something random, where I'm pretty sure you're not going to, I'm going to start with term 1 is 1.73. Term 2 is 2.0933. And term 3 is 2.532893. Not easy to see what I'm multiplying by. You would probably have to go to your calculator to figure it out. And so you would take two of them in a row and divide. And I was using 1.21. So if you took this one and divided by this one, you would get 1.21. If you took this one divided by this one, you would get 1.21. But it's not obvious. And so sometimes when there's decimals, you'll have to use this idea of dividing. Sometimes I can even use algebra. I can say, do you want a tricky one? You feel like you're ready for something a little bit tricky? Okay? The first term is 7. The second term is x. The third term, and I'm not going to make it easy. I'm going to make x a really not nice number. The third term is 40. What's x? Ooh. So the idea, you're trying, if I gave you nice numbers, you could probably guess and check until you got it right. But I specifically chose a not nice number to make it work. So you are sometimes required to use this common ratio idea. Okay, you got an idea?
Is it a decimal?
It will be a decimal. Here's the idea. Would you agree, whenever you take two in a row and divide them, so if I take x and divide it by 7, I'm going to get the common ratio.
Cool.
I could also get the common ratio by taking 40 and divide by x. Agreed? That's the idea. The common ratio has to be the same. So my x over 7 has to be exactly the same as 40 over x. If I multiply both sides by x, I would get an x squared on this side. If I multiply both sides by 7, I would get 280 on this side. By square root, the answer was I was multiplying by plus or minus the square root of 280. Whew. Not something you probably would have guessed and checked. We could type that into our calculator to find out what kind of decimal that is, but not easy. See. It's like 16 point something. It's like 16.8, 16.9.
Not a nice number.
Not a nice number. Okay. So this is a geometric sequence. And just like arithmetic ones, if we have the dot, 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 it means that it continues on forever. And we call it an infinite sequence then. If it stops, like if it doesn't have those dots, we call it a finite sequence. And sometimes geometric sequences increase. If you're multiplying by a number bigger than 1, does it make sense that each next term is going to get bigger than you had before? So that would be an increasing one, and ones that are increasing we call divergent because they get bigger and bigger and bigger. The opposite to the word divergent is, do we have it here? Do we have it in our notes? Yeah, we do. It's on the next page. Well, this one is going sort of all over the place, also divergent. But if it is decreasing, it will get closer and closer to 0. Okay? Right, you have a certain amount of money, and I say, give me half your money. And you're very nice, so you give me half your money. And the next day I come, and you still got money left. I say, give me half your money again. And if I keep doing that over and over again, you're never going to run out of money. But you're going to get closer and closer to nothing. Eventually you'll be like, I need to take this nickel and cut it in half and give you half of the nickel. I don't know how I'm going to do that. But it's going to get closer and closer to 0 if you keep cutting it in half. And so those sequences we say are convergent. Okay, let's go to example 1. So we have a sequence, and we can do this brute force method, like we did before, if you want to. Do you notice what you're multiplying by? Okay. So a key thing is noticing what you're multiplying by. And from 2 to 6, I multiply by 3, and because it's flipping between positives and negatives, I'm multiplying by -3. We're doing the 1 off this time. We always do the 1 off this time. You can write your notes right in that column. So you're multiplying by -3. So I could just go to my calculator and keep multiplying by -3 and list all 10 of them and find that 10th term. However, we already talked about the formula. You can take term 1, multiply by r n minus 1 times. So here, if I want to find term 10, term 1 is 2. I multiply by, I'll put it in brackets because it's negative, -3 to the 10 minus 1, which would be 9 times. Go to my calculator. And I get -39366. That would be term 10. Are our numbers getting bigger and bigger and bigger each time we multiply? Yes. So is this one convergent or divergent? This one is convergent. I'm going to do 2 questions, and then I'll give you some time to work on things, but you can circle 3, 4, 5, and 6.